Hello everybody, today's lesson video is going to cover on chapter 11, particularly in chapter 11.1, the introduction of Pythagoras theorem. The lesson objective today is to be able to apply Pythagoras theorem to solve problems. Do take note that I will be issuing the notes for this chapter when we meet back in school in week 3. Please bring along your chapter 11 workbook for your lessons in week 3. I hope that before you start on this video, you have already watched the other video that is before this in the SLS lesson. Okay, so what I'm going to do is to summarize for you the Pythagoras theorem over here. Okay, from the previous video, you would have understood how this Pythagoras theorem comes about, right? So this will just be a summary. Now for Pythagoras theorem, there are two main focus. Okay, firstly, the Pythagoras theorem can only apply to a right-angled triangle. For other kinds of triangle, Pythagoras theorem cannot apply. Okay, because only in a right-angled triangle, then we are able to identify the hypotenuse, and the hypotenuse has two important properties. One important property is that it must be opposite this right angle. So this is where the right angle is in this particular triangle, and opposite it we will always have the hypotenuse. Okay, in this picture over here, it is just for a pun, okay, that I have this hippopotamus. Okay, so that is just for fun. Alright, so now that we have been able to identify the hypotenuse, okay, through the right angle, that is one of the way. Another way is that the hypotenuse will always be the longer side. Although it isn't very easy for us to visually identify that the hypotenuse is the longer side, so we will just accept it as a fact for all triangles, or rather all right angle triangles only, that the hypotenuse will always be the longest side. Okay, in this diagram that I have over here, I have written this word opposite and adjacent. Right, these are not important words for us to discuss right at the moment. Okay, we will be discussing more about this when you enter Sec 3. Alright, so you may ignore these words opposite and adjacent first. Okay, so what we will focus on instead is that for this right angle triangle ABC, we have a right angle 90 degrees over here, and then we have the hypotenuse. So why is the hypotenuse so important? That is because it forms the skeleton to this formula, okay, that is a result of Pythagoras theorem. That is c squared equals to a squared plus b squared. Okay, so what does that mean? It means that, okay, in this particular context for triangle ABC, we have ab squared equals to b squared plus ab squared equals to bc squared plus ac squared. Okay, so if I were to highlight all this, hypotenuse is actually the side AB, which is this side over here. Then for BC square plus AC square, that is the remaining two sides. It doesn't matter, okay, in what order it comes about, because be it whether you add 2 plus 3 or you do 3 plus 2, they will both give you 5. So just like in this similar concept, okay, we have BC square to be this side here, and then after that AC square will be this side here. Alright, so essentially it must always be the hypotenuse square, or rather we call it the square of the hypotenuse, to be equal to the sum of the squares of the other two sides. Okay, so the square of the hypotenuse will be equals to the sum of squares of other two sides. So this is how I read it if I want to understand it in terms of words. But in general, okay, we will loosely, okay, describe Pythagoras theorem, right, in terms of c squared equals to a squared plus b squared, and only limiting it to a right angle triangle. Okay, so in example 1a, I am going to give all these questions into the notes that I will pass you next week. Okay, but so for now, just focus on the questions that I have typed out in the screen here. Okay, so in 1a, it says that there is a triangle shown and we want to find the length of the unknown side. So the length of the unknown side is over here. And we must be able to identify that this unknown side is actually opposite the right angle triangle, the right angle. So this is the hypotenuse. Okay, in short, we usually write HYP with a dot. Okay, but this is just for writing on the diagram over here. So now that I have identified where is the hypotenuse, the formula that we understand is c squared equals to a squared plus b squared for Pythagoras theorem. So therefore, c being always the hypotenuse only, that is actually my x. Okay, that is the reason why I have x squared over here. Then it will be equals to, okay, following the formula, right? And then a squared plus b squared. This a squared plus b squared is the sum of the squares of the remaining two sides. So it doesn't matter whether you choose 15 cm to be a or you choose 8 cm to be a. Alright, you can have 15 to be a, then 8 will be b. Or if you choose 8 to be a, then 15 will be b. Alright, it doesn't affect your calculation, it doesn't affect the presentation. So in my case, I have chosen 15 squared plus 8 squared. Then I use my calculator and I get equals to 289. So just use calculator for the calculation. Alright, I want you to take note, okay, just in case some of you are thinking this way, right, that 15 squared plus 8 squared is definitely not equals to, okay, not equals to 15 plus 8 bracket square, right? You can press into the calculator, all right? 15 squared plus 8 squared is actually equals to 289. Whereas if I put 15 plus 8 and then bracket square, I will be getting 529. So clearly 289 and 529, they are not the same. So please don't make this careless mistake, all right? Just press whatever you have what you have written out. So we get 289. Then x is equals to square root 289 or negative square root 289. Because we want to find out what is x, we are not trying to find out what is x squared. So we got to do square root. And whenever we do square root, we must do both. Okay, we must have both the positive square root, right, and also the negative square root. Okay, then you press this into calculator and we will get the answer 17 for the positive square root and negative 17 for the negative square root. Okay, but because x is actually the length of a triangle, okay, so we know that length definitely cannot be negative. That is the reason why, okay, we have to reject. So you must write this down. Okay, the bracket rej dot, we just write it in short form, rej dot, okay, to reject negative 17. Alright, by rejecting, it doesn't mean that you don't need to write it. You got to write everything that I have written in blue over here. Okay, then after that, you put this bracket reject over here. So the reason for rejecting, just to write it down for you to take note, okay, I reject because length can only be positive numbers, right? So that's why it cannot be negative, right? I hope you understand this concept. Now let us take a look at part B. Okay, part B did not give you a diagram. It is not all the time that a diagram will be given to you, so you must also learn to draw your own diagram and piece out the given information. So it says that there is a triangle ABC. The length BC is 7 cm, AB is 24 cm, and angle ABC is 90 degrees. So therefore, we are looking at a right angle triangle. Your right angle triangle can be drawn in this manner, or you can draw it in this manner. Okay, the orientation of the right angle triangle doesn't quite matter. So just decide on one. Okay, pardon me for not having straight lines, okay, because I do not have a ruler. So if I have my right angle over here, we know that angle ABC is equals to 90. So therefore, this must be angle B. This is where, sorry, not angle B, but the point B should be here. So I can have my ABC over here, or of course, I can also write it as ABC. It doesn't quite affect anything because this is just a sketch for your own reference. So now, okay, if I have ABC in this manner, okay, I put in the information that BC is equals to 7 cm. So BC is over here. I will have 7 cm. Next, AB is 24 cm. Alright, then now we want to find the length of AC. So the length of AC is this that we want to find, and that is the hypotenuse. So I hope you see now that recognizing the hypotenuse is very important, because Pythagoras theorem says c squared equals to a squared plus b squared, where c squared must be the hypotenuse. Okay, so the hypotenuse, we call it AC because that is the name of this length. So I will write AC squared equals to 24 squared plus 7 squared. Likewise, as per what I said in part A, it doesn't matter whether you choose 24 to be A or 24 to be B, because the answer will be the same to give you 625. So now that I want to find out what is AC, the opposite of square is square root. So square root 625 is 25. Then always remember, when we take square root, we need to do negative square root also. So that's why we have negative 25. Just like in part A, because length cannot be negative, therefore we must reject it. Hence the length of AC is actually 25 cm. Now we will take a look at part C, where we want to find the length of the unknown side for this triangle. And the unknown side refers to this xcm over here. Okay, so just like what we have been doing before, we always find the hypotenuse first, okay, because that is the important part about Pythagoras theorem. Okay, so let me just write briefly a summary of what we have been doing. So find which is hypotenuse. So in this case, the 25 cm is the hypotenuse. So when we identify the hypotenuse, then we apply the Pythagoras theorem. Okay, it is important for you to learn how to spell Pythagoras, because later on in this chapter, you are required to continuously be writing these terms. Okay, so apply Pythagoras theorem, which is c squared equals to a squared plus b squared, in a very loose description here. So therefore, c squared is actually the 25 squared, okay, and then the remaining sides will be 7 squared plus x squared. Because we are trying to find out what is x squared, so I will want to shift the 7 squared over here. Okay, oops, sorry. So I want to shift this 7 squared over to the left side, and the opposite of positive is actually this negative. Okay, so therefore I will put 25 squared minus 7 squared. Since 25 squared minus 7 squared equals to x squared, I can rewrite that as x squared equals to 25 squared minus 7 squared. Okay, if you're quick enough, okay, you can definitely skip this step. Okay, however, I do notice that some of you are not that quick yet. Alright, it is better to do things step by step. Okay, no point going too fast. So x squared equals to 25 squared minus 7 squared, and then we press calculator and we get 576. Since this is the value of x squared, we are trying to find out the value of x. So we must take the positive square root and also the negative square root. Okay, take note that just now I forgot to mention, okay, it should be the word or, cannot be the word and. Alright, therefore we get the value 24, otherwise negative 24, and more importantly, because the length cannot be negative, That's why we must reject the negative 24. Right? I hope that this explanation is clear for you to understand. After looking at the example 1A, B, and C, you may want to pause the video now and practice workbook exercise 11A, page 126 to 127, and work on question 2 and 3. You may want to do question 1 on your own to practice identifying the different hypotenuse, okay? But I will just want you to focus on question 2 and 3, okay, in terms of the practice. So work solutions can be found in a separate video. Okay, we have now come to the last example that I would like to go through in terms of Pythagoras theorem. So in this question, it talks about a diagram that is given, okay, a triangle ABC and triangle ABD, where both are right-angled triangles, and BD is 3 cm, CD is 4 cm, AD is 5 cm, and we want to find the value of x and y. To answer this question, we need to identify that there are two right-angled triangles. So the first right-angled triangle that we will see is this one over here, which is what I'm highlighting in yellow. The other one that we are able to see in the entire diagram is the bigger right-angled triangle, which I am highlighting in blue. Okay, so being able to identify these two right-angled triangles is very useful, right? We will first take a look at finding out the value of x first, okay, and apply our Pythagoras theorem. So let me erase the blue section. So focusing on this yellow triangle, okay, I'm going to highlight this part, okay, as involving the yellow triangle. So in the yellow triangle, right, I will notice that the unknown is over here, and the hypotenuse actually refers to this 5 cm. So now that I have identified the hypotenuse, okay, I will apply my Pythagoras theorem, which is c square, which is 5 square, equals to a square and plus b square. So I will get this equation, 5 square equals to x square plus 3 square. I want to find out what is x square, so I bring the 3 square over to the left side. That's why I have 5 square minus 3 square over here. Okay, I just skipped one step to write for me 5 square minus 3 square equals to x square. Pressing to the calculator, I will get 16. Then x is equals to the positive square root 16 or also the negative square root of 16. Okay, taking note that we of course must reject the negative value, hence we find that x must be equals to 4. That will be the answer for x. Now that I have found the answer for x, I will need to find out the answer for y. So let me erase the things here. To find out the answer for y, I need to focus on the bigger right-angled triangle, which I am highlighting in blue. Okay, y is actually in the hypotenuse, and then the remaining two sides of the triangle refers to BC, which is actually 3 plus 4 cm, and that is actually 7 cm. And then after that, AB, okay, which is x cm, and we already found out that x is actually 4. So using this information, I will be able to apply my Pythagoras theorem to see that y square, which is the hypotenuse, is equals to 4 square plus 7 square. Okay, so let me scroll downwards. My 7 square is due to 3 plus 4 bracket square. So I get this Pythagoras theorem equation, y square equals to 4 square plus 3 plus 4 bracket square. That is equals to 65. Then I need to find out what is the value of y. So I need to consider the square root, positive square root, and also the negative square root. And in this case, keying it into our calculator, we do not get a very nice whole number. In fact, we need to truncate to 5SF. So this is the truncated 5SF value. Then finally, our final answer is always in 3 significant figures. Okay, and I will have 8.06 or negative 8.06. And I will have to reject the negative answer because length cannot be in negative. Okay, I hope that with this you understand how to solve this question here. After taking a look at example 2, I would like you to pause the video now and practice workbook exercise 11A question 4 and 5 found on page 128. The solutions can be found in a separate video. We have now come to the end of today's video. Please complete the homework, found in exercise 11A of your textbook, page 231 to 232. I would like you to complete these questions. And then also, all this work is to be submitted when you are back in school, 15 June, Monday. A reminder is that on 15 June, you are to submit exercise 11A exercise 7A as well as exercise 11A. This is a summary of all the questions that you are supposed to complete. Please make sure that you submit this separately. Do on separate pieces of foolscap paper. Alright, that's all for today. Thank you everyone.